welcome back to the YouTube channel. Again, my name is Sabena from ECE31, and for today's episode of our Digital Electronics 2, we will be having our summative assessment for the final period, which is an application of Servo Motor as well as the Coin-Acceptor. So for this summative assessment, we will be having the automated candy machine using Pickit3, Servo Motor, and PIC16F1508 microcontroller. So this is presented by yours truly, Casablaneri, as submitted to Engineer Emmanuel Longares, our Digital Electronics 2 instructor. So to provide you a glimpse of our problem, we are requested or required to create a PIC microcontroller-based project wherein a Coin-Acceptor and Servo Motor is being applied. So for our objectives for the summative assessment, we aim to create a paper that depicts the logic of the program code on our mplab software. Second is to create an mplab source code that can be used for the application of the Servo Motor and Coin-Acceptor to meet the problem requirements. And the third one is to use the Pickit3 with the mplab and electronic components to test the code and perform the application in the actual circuit on breadboard. So for our equipments and components, we will be using the PIC16F1508 controller, a 220 to 1 kilo ohm resistor, our servo motor, of course, our 3 LED, any color of your choice, our breadboard, connecting wires, Pickit3 as well as our power supply, both 12 volts and 5 volts as well. So for our introduction, technically speaking, servo motors, okay, also known as servo, are electronic devices which are linear actuators that rotate and push parts of a machine, okay, which is giving the machine's function its precision, okay. So servos are mainly used on angular or linear position and for specific velocity and acceleration by setting the program or the command and our source code. So moreover, servos are controlled by sending an electrical pulse, okay, of variable width or pulse width modulation or PWM that we encountered in this course subject. So notably, there is a minimum pulse, a maximum pulse, and a repetition rate for our servo. And technically, a servo motor can usually turn from 90 degrees in either direction for a total of 180 degrees movement. So for the application of servo motors, these are usually applied in industrial applications, in our factories, in our robotics, of course, in inline manufacturing, okay, on our factories, as well as pharmaceutics, and on our food services and industry. So for this summative assessment, since food services is one of the necessities of the Filipinos, okay, it's one of the high demand industry in the Philippines. One of the application that I thought of doing for the summative assessment is a servo motor application as well as the Coin-Acceptor application to our candy machines. Because if you can still remember, back when we were just kids, we are inserting coins, okay, to our candy machine, and this requires us to turn a knob in order to get the candy from the machine after dropping coin to the coin slot. But since we are taking up electronics engineering and our goal is to make things more convenient and easier, and since we are in the pandemic nowadays, we shall minimize the contact of hands to things by the people to prevent the transmission of the virus. So I thought of an idea of making the operation of the candy machine automated, wherein after a person, or let's say a kid, inserted a coin to the coin slot of the candy machine, the servo motor will automatically adjust its angle, okay, that will open the candy machine's barrier from this hole where you will be able to get the candy, okay. And after inserting the coin, it will automatically dispense the candy without requiring human contact or interaction with the machine to prevent the coronavirus transmission. So with this idea, after inserting a coin to the coin slot, okay, you don't have to turn a knob anymore. You don't have to turn this knob anymore, but instead, it will automatically send signals to our servo motor through pulse width modulation to signal that the machine should open the candy door knob, okay, the candy machine knob, and to dispense the candy to the customer who inserted the coin. So that's the logic behind my application, which we will be making on our MCC. So with that, let's start. So to give you an idea on the procedures that we will be using in creating the source code, you can actually go to this website, okay? You can actually go to this website, which is the Microchip developer, and you can actually get some ideas from this site, controlling an analog servo, to understand how can we control the analog servo using our MCC. So now we will be proceeding to our source code. So to start making the project or the source code in mplab, let's click a new project here, okay, and let's select standalone project, and then let's select, okay, the PIC16F1508, which is the IC that we will be using for this experiment, just like what we are using here, okay. So that's PIC16F1508, okay. So after that, let's click next. So let's select our compiler here. Let's click next. And then let's select our project name. So my project name will be Casabuena. My surname. Casabuena Finals DG. Like. Okay. And after that, let's click finish. And let's just wait for it to load up. So after this one, we will be clicking this save button here, and our MCC compiler will pop up. Okay, and this will allow us to edit our parameters here in mplab. Now, from this perspective, we shall select the right package of our IC, okay, based on what we purchased. So this is the right package of the PIC16F1508 IC. And then so now from our system module, okay, we have to select here, okay, we have to add PWM4, okay, for our pulse speed modulation. So as you can see here on the peripherals, it is already added. And then we shall add another one, which is the timer 2, okay. Let's add it on our peripheral, okay, it's already added. So to continue, for our individual settings, okay, our settings for PWM4 is that the enable PWM should be checked, and the enable pin output should be checked as well. So our timer will be timer 2 because it is the added one, and then our duty cycle is 50%, okay, and PWM polarity is active underscore high, okay, this one, and all of the PWM parameters is set to be the default parameters. So for PMR2, okay, our timer 2, the timer should be enabled. Okay, it should be checked. And then our post scaler should be 1:1. Pre-scaler is 1:64. Okay, 1:64. And then our time period will be 16 milliseconds. Okay, let's set it to 16 milliseconds as suggested by the Microchip website, which I will be giving the link on the description box on this YouTube channel. Okay, and after that, we will be after that, considering our interrupt module here, okay, we will be considering the default settings. Okay, there should not be type at all. So after our interrupt module, we have here our system module. Okay, let's go to it. So our oscillator select should be internal. Okay, internal oscillator, or this INTOSC. Okay, it should be click. And then our system clock select is FOSC. Our internal clock should be 4. Okay, should be 4 megahertz high frequency. And after that, let's just consider the default settings for our system module. After this one, we shall go to our pin module. So for our pin module, since we will be using this servo motor application to get the machine, I will be considering 3 LEDs as our output, but this will just be connected to in series connection with one of our output pins here on our PIC16F1508. So I will be selecting the output on RA5, okay, RA5 of our IC. So here it is. So this will be our output, so it should be green, okay, and our input, our digital input, which is the coin, will be inputted on our RA4 here, okay, as you can see here. So RE4 will be the input for our coin, okay, our digital input, and the RE5 will be our output, which is the indicator, okay, the indicator for our candy machine, which indicates or signals that it already accepted the coin and it will dispense the candy already. So with that in mind, let's edit our name here. So RE5, just like what I've said, will be the output, okay, will be the output for the candy machine. So it should be our LED, okay, our LED lit. And for our RA4, it will be for the coin input, okay? So coin input. So after that, let's consider, since we will be considering coin as our input, it should be tick as WPU, okay? And after that one, RC1 should be tick output, okay? Because it is where our servo motor will be connected, okay? And our RE5 will be our output for our LED. So after this one, let's generate. Okay, let's just click OK here. And there should be a pop-up here saying generation complete. Okay, wait a moment. Okay, generation complete. Let's create the source code. Now, after setting up the parameters in our mplab, okay, so here in the pin module, actually, you can untick WPU since we will be using a pull-up resistor, using a potentiometer later on our circuit, okay? So after this, let's go to our main.c file, okay, here on source files, and then main.c file. And then on this part of the mplab, we will be having our source code. So for our application, I considered this source code. Okay, so under this void part here, we will be initializing the system, and then this is important, the uint16_t duty cycle to declare the function of our duty cycle on the while loop later on. So this duty cycle is equal to 0 is also used to clear out any stored value in the program. So for our program, or for our source code, here in the while loop, we add an if statement wherein if coin input, okay, so if you can still remember, our coin input here is this one, which is our digital input from our Coin-Acceptor, okay, if our coin input underscore get value, okay, if it gets a value of equals to 0, it will perform this function wherein the LED will be set high, okay, the LED lit, this on here, on this end. Okay, so here on this end, if let's say for example we inserted a 1 peso coin on our Coin-Acceptor, okay, if it gets a value, then it will perform this function wherein the LED here on this output, and this pin number 2 will be turning on, okay, and the servo motor will turn its motor, okay, or its blade, meaning with the same logic with our candy machine operation, when a 1 peso coin is inserted to the coin slot, then the candy machine knob, okay, or opening before the candy is dispersed will be opening, okay, and the knob will be turning or rotating automatically without human interaction. So that's the logic behind that. And we put an else statement here wherein if we do not insert any coin, or let's say we do not, a customer did not insert a 1 peso coin to our candy machine, then our else statement will perform this code wherein the LED will be set low or it will not be turning on, and our low duty value here is considered to be 30. So in this PWM4 underscore low duty value, this will uh, allow our servo motor to rotate automatically its blade. So that's the role of our low duty value program here, which we also use here. We declare it here. So that's the logic behind the source code for this summative assessment application. Now, to construct our circuit, we will be needing a PIC16F1508 here, the small IC, a Pickit3, our Pickit3 connector, okay, wherein this arrow here signifies the MCLR, okay, the pin number 1 of our Pickit3. So let's connect our IC here, okay, taking note of the notch of our IC for the right pin configuration. So let's put it here. And then for our connection, our MCLR1, which is this yellow wire here, let's connect a yellow wire. This will be, as we see on the diagram, this is on the pin number 4 of our IC. So this one here is connected to pin number 4 from the notch. So it's 1, 2, 3, and 4. Okay, so VDD, okay, VDD is on pin number 1. VDD is the second wire here, which is the orange wire here. So VDD is this orange wire here, which is on the pin number 1 of our IC. So the next one will be VSS. Okay, VSS is this red wire here. VSS is the ground. So let's connect it here, and let's connect it on the 20th pin. This is connected. Okay, our VSS or our ground is connected to the 20th pin of our IC here. Okay. Okay. So based on our pin configuration, okay, our LED or our output will be connected on the pin number 2 of our IC. So pin number 2, which will be our output. Okay, let's select a green wire for that. Okay, pin number 2 for the LED is here. Okay, let's connect it here on this side. Okay, so on this wire we will be connecting an LED, okay, and a resistor. Okay, so let's connect an LED. So taking note of the polarity of our LED for right connection, then let's connect a 360 ohm resistor to our LED. And then actually you can use 3 LEDs here, okay, for complexity of the circuit. But just to demonstrate, I will be using only one LED first to demonstrate the construction of the circuit. So let's ground this. Let's ground our resistor. So before we forget, our data for our Pickit3, okay, is connected to our 19th pin, okay. So this black wire here, okay, this black wire here is connected to our 19th pin here. I mean this brown wire, okay. This is connected to the 19th pin of our IC here. And then the last wire, which is the black wire, is connected to the 18th pin of our IC. So let's get another wire here. So this will be our IC DPVLK or PGC connection or our clock, okay. So let's connect it to the 18th pin, okay. So this will be our connection, okay, before we connect our Pickit3 to our mplab IPE, okay. So now let's connect our Pickit3 to our mplab IPE to program our IC. So now to connect our Pickit3 to program our microcontroller or our IC, let's make sure that our device here is the right IC that we will be using, which is the PIC16F, okay, 1508 here, okay, and then let's connect our Pickit3 to our mplab IPE. So let's just wait for a notification that will allow us to edit our simulation settings. Okay, so this will allow us to edit our simulation settings here, wherein we will be editing our advanced mode. So let's just wait for it to load up. Okay, so we have to edit our advanced mode here, okay, by typing Microchip here as our password. So let's log in, and then let's go to power, and then let's click here voltage level is 3.125, and then power target circuit from Pickit3 should detect, and then let's click operate, and then let's browse the hex file that we will be using for this summative assessment. So after the hex file has been loaded successfully, let's click program. So let's just wait for the notification to say that programming is complete, and after that our circuit is ready to go. Okay, as you can see, programming complete. So now we will be setting up to construct our circuit. Now to show you how the circuit is constructed, okay, with our 12 volts Coin-Acceptor and our servo motor, okay. Also we will be using alligator clips, okay, and DC jack as our improvised for our 12 volts voltage supply. So for our servo motor, this is the blade, okay, of our servo motor, wherein we connected it already using our screw. So for the connection, this yellow wire here will be our connection to our IC, okay. So let's connect this to our pin number 15 of the IC, which is the pulse width modulation 4. So let's count. So it's 1. So this is 11, 12, okay. 11, 12, 13, 14, 15. So this is the connection of the servo motor to the circuit. And then for our red wire here of the servo motor, this is connected to the positive terminal of the voltage supply. So let's connect it here. Okay, here on the color red. And then for this brown wire here, this will be connected to the negative terminal of our voltage supply. So let's connect it on the negative supply or on the common ground of our 5 volts. So let's put our servo motor here on this side. And then after that, we connected an LED, okay, an LED to our IC, connected to the second pin of our IC, this green wire here, okay, it is connected to the green wire there. And then we connected a 360 ohm resistor in series with our LED, okay, be mindful with the polarity of the LED, so it will light up as our indicator for the candy machine, and then ground the series connection. And then for our coin acceptor input, okay, connection to the circuit or to our breadboard, this white wire here will be connected to our pin number 3 of the IC or our coin input. So here on the IC, let's count 1, 2, 3. So this is the connection of our coin acceptor. So before we forget, let's just remove the connection of our Pickit, okay? Let's remove our Pickit so our circuit will be more organized. So let's remove the connection here. Okay. So that you can see the connection clearly. Okay, let's remove this one. And after that, we will be connecting our common ground, okay? Common ground of the voltage supply, the 12 volts. Okay? This is connected to the common ground here, which will be connected, okay? Which will be connected to our coin acceptor, okay? So that this circuit will be connected to the coin acceptor for it to allow a digital input, which is our coin. So this will be connected here on this alligator clip. And after that, you can see here, on our DC jack, the positive terminal, okay? Let's move a little. The positive terminal of our coin acceptor, okay, is connected to the positive of the DC jack here, and the negative is connected to the negative terminal of the DC jack here. So this will be the source of our 12 volts. And for our 5 volts voltage supply, we will be using a 9 volts battery to power our breadboard, okay? But since since IC is only allowing 5 volts voltage supply, for it to work properly, for it not to be destroyed, we will be using a power module here, okay? So we will be connecting the 9 volts here as our power supply. So overall, this is our coin acceptor connected to our breadboard, and this is the connection of our breadboard, okay? So you can actually use 3 LEDs if you would like to make your project more engaging and more aesthetic, since we are dealing with candy machine. So this is our final circuit with our servo motor here. Okay, so now we will be proceeding with testing of the circuit. So to start testing our circuit, okay, before we proceed with the testing, I just want to remind you that we consider putting a 10 kilo ohm potentiometer in our breadboard to avoid our IC from being destroyed, okay? Since we will be inserting or either connecting this 12 volts coin acceptor to our circuit breadboard, then it is possible that the IC may be damaged. So for this coin acceptor wire here, which is connected to the input, before we connect it to our IC directly, we should put or connect a 10 kilo ohm potentiometer as our pull-up resistor. Don't forget that. And after that, we will be connecting a 9 volts battery to our power module, and then these alligator clips are used to connect our DC jack to our 12 volts power supply, which will power our 12 volts coin acceptor. So now, we will be connecting our positive 12 volts here to power up our coin acceptor. As you can see, our coin acceptor is already powered up. So now to test our circuit, okay, and if our servo motor is functioning well, we shall insert a 1 peso coin to our coin acceptor, and once it was inserted, the LED here will light up, which will serve as our indicator that the candy is being dispersed by the machine, and the servo motor here, which is a symbolism for our candy machine doorknob, okay, will open, okay, and it will move, meaning it will open the doorknob for our candy machine to disperse the candy. So for our first test, let's turn on our 5 volts voltage supply here and watch this LED as it light up when we insert a 1 peso coin, and this servo motor here will turn its motor. So for our test, again, focus on the light here, okay, it will light up when we insert a 1 peso coin to our coin acceptor. So let's start. For our first 1 peso coin, okay, as you can see, our servo motor turned, okay, and the LED light up, okay, meaning a candy is being dispersed by the candy machine. Now for our next step, or next test, okay, focus on the LED and on the servo motor. So let's go ahead. Okay, as you can see, our servo motor turns as well when the LED light up. So let's try that in one more time. So focus on the LED. Okay, 1, 2, 3. Okay, it turned as well for the third time. Okay, focus again on the LED. So for the fourth time. Okay, as you can see, it turned again. So for more proof, you can hear the sound of the servo motor when it turns when we insert a 1 peso coin here. So let's insert again. Okay, as you can see, that's the sound of our servo motor rotating its motors. So this application of our servo motor control, okay, to control our candy machine and to promote automation to prevent the coronavirus transmission is a very good idea, which we can use not just in candy machines but in food enterprises, which requires less human contact since we have pandemic nowadays. Knowledge about servo motor is a great help in better understanding our mechanical machines and our electronic industries, which uses this kind of electronic components and devices. So that concludes our summative assessment for the final period. I hope you learned something from our summative today, and I hope I will be seeing you on our next vlogs. See ya!